All right, hello and welcome. So over the past couple of videos, we've been talking about exponential functions. Today we're going to move on to logarithmic functions, which are inverses to exponential functions. So to see how a logarithm works, we're going to think about it in terms of solving equations. So just as a quick example, I know that if I see something like x plus 2, and I want to cancel out the 2, I could subtract. Right? I know that if I see an equation that says 2x equals something, and I want to get rid of the 2, I can divide. I know if I see x to the power of 2, and I want to get rid of that 2, I can do a square root. And up until this point, we haven't had to solve equations where we see 2 to the power of x. Well, since we've been talking about exponential functions, now is a good time to look at how to solve those equations if we are given them. So the way that I'm going to get rid of the 2 in this instance is to use a logarithm. So when we write a logarithm, right, the word log is short for logarithm. The little number next to the g, that little subscript, is our base. So whenever we convert from an exponential form into a logarithm form, basically all we're going to do is use whatever the base of the exponential was as the base of our log. So if we're looking at some examples of what we're going to need to be able to do with this, first thing we're going to need to know how to do is switch back and forth between logarithm and exponential form. So if I'm looking at number 4 over here, and I see 2 to the power of 7, if I want to switch that into logarithmic form, I just want to make sure that the base of my log matches the base of the exponential. So since I see 2 to the power of 7, I know that my logarithm needs to have a 2 next to it. And so whatever I put on one side needs to also go to the other. So my logarithm form would be 7 equals log base 2 of 128. As another example, on the one below it, on number 7, I see 7 to the power of negative 2. So that means that my log needs to have a base of 7. So in logarithmic form, that would say negative 2 equals log with a base 7 of 1 over 49. So because logs and exponential equations are inverses, I can also take logarithmic equations and flip it the other way. So if I see log 15 of 225 equals 2, I can use a base of 15 on both sides to rewrite the expression. So that would tell me that 225 equals 15 to the power of 2. On the second one, I notice my log has a base of 3. So I'm going to put a base of 3 on both sides, and that will tell me that 1 over 27 equals 3 to the power of negative 3. So that's converting between logarithmic and exponential form. The only other thing that we need to know for today is how to evaluate logarithmic expressions. So what we're going to do is think about what we were just talking about, like in terms of bases and exponents, and try to ask ourselves what this log is trying to get us to do. So if I'm looking at number 10, and I see log 4 of 64, I know that that needs to equal to something. And I know that I can rewrite a log as an exponential equation by matching the base to the other side. So I'm really trying to figure out what exponent goes with 4 to make 64. And so using a calculator, I can figure this out, and I might play with it a little bit, or if you just know your powers of 4, you might know that 4 cubed is 64. So the answer to this question is 3. Similarly, so number 11, log 2 of 64 equals to a number. So I know if I put a base of 2 on both sides, I'm trying to figure out what exponent goes with 2 to make 64. And if I play with it, I can find that 2 to the power of 6 equals 64, so the missing thing was the 6. Now, most calculators will evaluate logs for you. And if you're going to use Desmos or a calculator, you just need to know where to find it. So in Desmos, if I go and type in the bar on the left, and notice there's a little keyboard button on the bottom left corner. So when I click on that, it'll bring up the number pad. To find logarithm, what you're going to do is click function and click all the way over to the right. And so you'll notice that it's in the middle column towards the bottom. So if I click on that, I can now type in my base and my number, and it will give me my answer in the bottom corner. And so just to double check, if I do 2 to the power of 6, it equals to 64. So we know we've done it right. So we can pick pretty much any of these and do the same thing. So for example, if I wanted to do log 27 of 81, I'm going to press function, log, fill it in. Notice it gives me a decimal. So if I click the little fraction on the side, like right next to where it says log, like right to the left of it, it'll convert that into a fraction. So it gives me 4/3. And again, just to make sure I'm doing everything right, if I do 27 raised to the 4/3 power, it matches the 81, so we know we've typed in everything correctly. One more thing to point out. If I see one like number 17 where it says log 10, I can type it the way I see it. So log 10. type in the 0.00001, get -5, or notice that the button next to the log with the little base just said log by itself. Notice how these give me the same thing. And the reason for that is if I don't type a base, it is assumed that the base of my log is 10. Right? So again, if I don't type a number for the base, we just imagine that there's a 10 right there. So this won't work for anything else but log 10. So if you just want to get used to always typing the base, that's fine. Otherwise, just a log by itself will work if you have a base of 10. And that's all we've got for today for our intro to logarithmic functions. Have a great day, and I'll see you guys next time.